Polynomials that we are adding. We are going to put together like terms. Oh, and I forgot to get you that test. I'll get you that test in just a minute. Yeah, maybe. Might be easier for you to follow along or not follow along. So I am going to put together like terms. I have 2h squared minus 3h squared. Okay, so 2h squared minus 3h squared. And then I have negative 5/3 h and 11/3 h. Okay, so minus 5/3 h plus 11/3 h. So remember, when you are putting these together and you're adding and subtracting, the variables stay the same. So the h squared is going to just stay as h squared. And when I say 2 minus 3, I get negative 1. So that takes care of my h squareds. Yes? Solving. Okay, right. We're not solving, but if you put it in standard form, you have to simplify and combine like terms, and then you want to put them in order from greatest degree to smallest degree. Okay? So 2h squared and negative 3h squared are definitely like terms, right? So we need to combine those. Yes. So that is negative 1h squared. And then I have negative 5/3 h plus 11/3 h. When you're adding and subtracting fractions, you need to find and keep the same denominator. These already have the same denominator. Okay? So I need to just add the numerators. Negative 5 plus 11 is how much? 6. And if I do 6/3, what does that simplify to? What is 6 divided by 3? 2. So my final answer here is negative 1h squared plus 2h, because 6 divided by 3 is 2. Questions on that? So yes, you do have to combine like terms, and you also need to simplify if you can. So what is my leading coefficient? Well, first of all, is that in standard form? Am I going from greatest degree to smallest? Yeah, because this has a 2 and this has a 1 that's not there. So my leading coefficient is going to be negative 1. Right out front. In front of the whole set of polynomials, negative 1. All right, any other quick questions? Number 10. Okay, so write each in standard form and identify the leading coefficient. So here I have negative y to the third plus 3y minus 3y squared plus 2. What is my coefficient on 3y right here? What is my coefficient? Or not coefficient, I'm sorry. Exponent. 1 on the y, right? If I'm putting it in standard form, that means greatest degree to smallest degree. Do I have any like terms here? No, I don't. Okay? I do not have any like terms. So I just need to put them in order from greatest degree to least degree. So which of these terms has the greatest degree?
3y.
No.
3y. Oh, 2.
No. Which one of these has the greatest degree on it? Negative y to the third, because that has a degree of 3, right? What would be next? I've used that one. Negative 3y to the second. What comes next? 3y. That's 3y to the first. And then finally, plus 2. What's the degree of any constant? 0. Only variables have degrees, right? I'm not talking about exponents because we could still put a 1 in it, but a degree is slightly different than an exponent. Okay? So what is my leading coefficient for number 10? Negative 1. Yeah. There's nothing there, but it would be a negative 1. There's a negative sign, but no number, so it's negative 1. All right, so that's all the time I can afford with these. Let me tell you, and maybe it was not explicit enough on the back, classify each polynomial according to its degree and number of terms. I'm looking for the words, okay? So number of terms, maybe this has 3. If this is 3, what do we call a 3-termed polynomial? Trinomial. So I'm really looking for the word trinomial there. And what is the degree of this polynomial? 2. And if you look in your notes, there was a graph for a table. And for a second degree, the fancy word is quadratic. Quadratic trinomial. Yes, it says 2 words is what I'm looking for. Okay? All right, so if you are ready to turn those in, I will take those. If you're not, please get it done by tomorrow. Okay? All right, let's go to the bell work. Bell work, we are on day 3. And we are adding and simplifying these polynomials when they are added together. So number 1 says simplify x plus 3 plus 4x minus 7. And the second one is x squared minus 3x plus 8 plus 5x plus 2. Right now, do those at your seats. Well, I don't know. Did I take attendance? I don't even remember. Too much to do in one day. 44 minutes is not enough time. Really is not. So TJ's not here. Laura, Emma, Latrell, Daniel, Victoria, Debonair's not here. Terrence, Leslie, Jeremiah, Deanna, Esmeralda, Kenzie, Sanaya, Charles, Camille, Clavin. Okay. Examples of the homework. Huh? Did you turn it in? Or you have it to turn in?
I don't have my homework.
Have you studied for this recently at all? Okay. All right. Here you go. Might need a calculator. I'll get you a calculator. There you go. All right. So you are combining, finding like terms. Okay. Do I have Latrell? Come on. Do I have any like terms here for number 1? 3 and 7, yes, -7. And what about the other two? Are those like terms? So putting those together, I have x plus 4x, and I have 3 minus 7. So I am doing this horizontally, okay? The number in front here would be a 1. 1 plus 4, you only add the coefficients, gives me 5x. And 3 minus 7 would be -4. So my final answer is 5x minus 4. How many have that at their seats? Good. Nice. Any questions about that? Yeah. If you ever played War with cards, you guys play with cards, playing cards, you know, a deck of cards. Do you play cards much at all anymore? No? No? If you ever played War, are you familiar with War? Which you look at the cards and you say which one's higher. So 7 as a number, as a digit, is higher than 3, but it has the negative with it. So you subtract and take the sign of the larger digit. Okay? All right, let's take a look at number 2. X squared minus 3x plus 8. What did we call that? Polynomial. What kind of polynomial? 3 terms. Trinomial, yes. Trinomial of degree 2. So this would be a quadratic trinomial. This is the fancy word. Quadratic. And we're going to get into quadratics a lot next semester. This would be, because this has a degree for the polynomial of 1, a linear binomial. Okay? All right, but we are just simplifying these. So as I look, x squared, do I have any other x squareds? I do not, so that's going to be the only one there. Next up, I have -3x. Do I have any other x terms? 5x. So I'm going to put -3x plus 5x. And finally, I have my constants, 8 and 2. So x squared, there is a 1 in front. That is 1x squared. -3x plus 5x, you only look at the coefficients. So -3 plus 5 is going to be 2x. And 8 plus 2 at the end makes 10. You check, make sure, yep, I only have 1x squared, I have 1x, and here I have 1 constant. So you don't have any bases that are repeated. This is your final answer. Any questions about that? Okay. All right, let's go to our notes. We are multiplying. So yesterday we did addition and subtraction, except there's not really any subtraction. Today we are multiplying. Okay? So multiplying is not too bad. We are going to be using the distributive property. If you remember, the distributive property says that if you have something on the outside, multiplying by a set of parentheses, you multiply whatever is on the outside times whatever is on the inside. Okay? And sometimes that will include multiplying powers times powers. So if I had a to the 7th times a to the 3rd, you keep the base, in this case, which would be a, and what do you do with those exponents? You add them. So that gives you a to the 10th. So when you multiply like bases, you add the exponents. All right? If they have the same base, yes. If I had an m in there, then you would add the exponents on that m power, on that m variable. Okay? So let's take a look at our first example. Negative 2x times 4x squared plus 3x minus 5. I am multiplying negative 2x times all of these. All right? I am going to write it all out. So negative 2x times my first term, 4x squared. Negative 2x times the next term. Ooh, I forgot my x already. Times 3x and negative 2x times negative 5. So then when you multiply, you if they're just numbers, you multiply those numbers, those coefficients out front. Negative 2 times 4 is negative 8. X, there is no exponent on it, but you know there is a 1 there. So put a 1 on it. And now you are multiplying x to the first and x to the second. Just because they're not beside each other, they are still being multiplied. So when you're multiplying powers that have the same base, you add those exponents. And this becomes x to the 3rd power. Okay? And the next one, I have negative 2 times 3. That's going to be a minus 6. This is x to the 1st power and an x to the 1st power there. Add those together, and you get x to the 2nd power. And finally, negative 2 times the negative 5 gives you a positive 10. X to the 1st, that's the only x there, so it remains x to the 1st. Make sure you don't have any other like terms. This is x to the 3rd, x squared, x to the 1st, so I don't have any other like terms that I need to combine. Okay? All right, so let's see. Any questions about that? You've had distributive property before. Last chapter, we multiplied powers. So let's see what you can do with this problem A. Negative 3x times each of these terms. Okay? Try that on your own. Taking negative 3x times the first term, negative 3x times the second, and negative 3x times 1. See if you can do that on your own at your seat. Calculator. Yeah, what do you need? Calculator? What? Hang on just a minute. I'm gonna get him a pencil. Okay. Remember, when you are multiplying powers that have the same base, you add those exponents. All right. What did you ask me for? Oh, okay. Okay. So multiplying. Okay. Here's what you do. Negative 3x times the first term, 4x squared. Negative 3x times my next term, negative 2x. And negative 3x times the last term, which is 1. So negative 3 times 4, negative 12. Remember, this is x to the first power, so I'm multiplying x here times x here. They have the same base. Add those exponents. So that becomes x to the third power. Negative 3 times negative 2 is positive 6. No exponent, put a 1 on it. They have the same base. Add the exponents. So x to the 1 plus 1 is x squared. And negative 3 times 1 is minus 3x. You could put a 1 on it, or you could leave it like it is. This is and should be your final answer. Anybody get that for an answer? Nice. What? How'd I get the squared? Because this x to the first on the outside has an exponent of 1, and this exponent had 1. They have the same base, so I add the exponents of that base of x. 1 plus 1 is 2.
So wait, cubed them in.
Oh, the cubed, I took the exponent of 1 here plus the exponent of 2. 1 plus 2 gives me 3. Okay. All right, let's do B together. Okay. So 2mn, that gets distributed with everything on the inside, and this is actually distributive property. Okay. Terrence, never mind. Thank you for being on your calculator. Did I tell you that I didn't get much sleep last night? Can you tell? No? Okay. 2mn times 6mn to the third plus 2mn, that's what I'm multiplying by, times my second term, 5m to the third n to the second, plus 2mn times 3. Now, I'm writing this all out. I think if you write it out, you will make fewer mistakes. Okay? I can't guarantee that, but I think that is true. That is up to you. So, 2 times 6, multiply your coefficients. That's a 12. M to the first, put a 1 on it. N to the first. Times m to the first here, 1 plus this 1 gives me m squared. And n, I have 1 plus this 3 gives me 4. 2 times 5 is a positive 10. M to the first times m to the third is m to the fourth. N to the first times n squared is n to the third. And 2 times 3 is 6. M to the first, n to the first. Now, is this written in standard form? It is not, because this has a degree of how much? No? 6. You add these two together. Okay, that has a degree of 6. This has a degree of 7. So if I were to rewrite this, and it doesn't say this, but if we did tell you to, you would put 10 m to the fourth n to the third plus 12 m squared n to the fourth plus 6mn. This is standard form. And you're like, Miss Thede, why does it make a difference? It's the same thing, right? Well, it doesn't until we ask you about what its leading coefficient is. If you write it and keep it like this, you would say 12. If you write it in standard form, your leading coefficient here is 10. So only when we are asking you what the leading coefficient is and when we're telling you to put it in standard form does it make a difference. Does that make sense? Okay. Any questions on B, problem B there? All right, let's get to example 2 right here. And then we will probably call it a day. So, simplifying expressions. Notice we still are just combining these things by distributive property, except we've got a minus sign here. Do we subtract when it comes to polynomials? No, we do not. So, I'm going to set this up. I've got 3n. That's going to get distributed with everything inside. We do not subtract. So I change this minus sign to a plus sign, and I'm going to take this times -1. You are changing each sign, okay? So let's see what that looks like. I'm going to try to write small. So 3n times 6n to the third. Then I have, no, I want green. 3n times -4n. Then I am going to take this -1 times 2. So this is going to make it -2 here. Instead of multiplying everything here, because there's an actual number here, I'm going to take the -1 times that. And that's going to end up changing all my signs. Okay? So before, we took -1 and changed the sign of everything inside. Same type of deal, only since I have this number out front, I'm going to change that number. And since that number is distributed, it's going to end up changing all of them. So this is going to be a -2 times 9n to the fourth and -2 times -11. Okay? I see a puzzled look. Question, Jeremiah? Okay. All right, so let's put this together. 3 times 6 here is 18. N to the first times n to the third. Add those exponents because they have the same base. So that is n to the fourth. 3 times -4 is -12. N to the first times n to the first. Add those exponents. Then I have -2 times 9. That is -18 n to the fourth. And -2 times -11 is +22. As you look at this, are there any common or like terms? There are. What are they? Yeah, these two are like terms. So you need to combine them. So if I say 18n to the fourth minus 18n to the fourth, what do we get? 0. 0n to the fourth. But what is 0 times n to the fourth? 0 times anything is just 0. So these are going to cancel out. So my final answer is negative 12n squared plus 22. Okay? All right, so I want you to now take out homework number 2, which is at the end of your homework packet. And let's get started on some of these. Homework number 2. This is not due until Friday. So we will be doing a little bit more work with this. So this is homework number 2. It says multiplying polynomials by monomials. So when you multiply, right here, this is f to the first. So this would be f to the first times the first term inside, f squared, plus f to the first times 2f and f to the first times 25. So you have two powers that have the same base. When you multiply two powers that have the same base, you add the exponents. So this becomes f to the third plus, coefficients go in front, so pull the 2 out in front for the second term, f to the first times f to the first, add the exponents, that becomes f to the second, and f to the first times 25, 25 is a coefficient, so that's plus 25f, and you can put a 1 on it if you want. Okay, you should be able to do tonight these first 4 problems. You cannot do until after tomorrow the bottom 4 on the front page because this is solving the equations. Although some of you might be able to. Let's take a look at the back. Hopefully you didn't see that answer. Pearl and Ted both simplified 2x squared times that trinomial. Is either of them correct? Explain your reasoning. So on the back of page 2, or homework 2, they both are simplifying this multiplication problem. Which one is correct? Can anybody tell? Who is correct? Pearl is correct. Why is Ted wrong? Ted? Ted, what about Ted? Ted is correct. Why is Pearl wrong?
She didn't have the exponent. So two, she don't put 2. Isn't it supposed to be like 4?
For which number?
Well, the bottom.
For 8. 8x to the power of 2. You got to add the other.
Yeah, so this is 2x squared. This should be a 4x. 2 times 4 is 8. 2 plus that 1 should be a 3. So Ted is correct. And then you should explain what Pearl did incorrectly, okay? And maybe you write it out. 2x to the second times 4x to the first does not equal 8x squared. It should equal 8x to the third, okay? All right. So